Okay, good afternoon, everybody. I would like to present my paper, and the title of my paper is Preliminary Study on the Basic Characteristic of Isopropyl Esters Used as Insulating Liquid. As we know already that most of transformer, both power transformer and distribution transformer, contain oil inside the tank. This is because transformer containing oil are more efficient than the dry type of transformer. Until now, until now, mineral oil is still the most favorite choice, but the oil has some disadvantages. The oil is not biodegradable, so the oil is considered not friendly to environment. Also, the oil will run out someday in the future because the oil is extracted from their petroleum oil. So the oil is considered to be non-renewable. Currently, many countries in the world, especially in Europe, there is an emerging development of with turbine to produce electricity on offshore. This electricity need to be increase their voltage before being transmitted to the customer. To increase the voltage of the electricity, it needs the transformer. So transformer should be located there. The problem arises then if there is a leakage on the tank of the transformer. The mineral oil leakage will cause a serious pollution to the ocean or surrounding. So we need oil which is biodegradable. Also, we need the non-toxic oil. And natural ester seems to meet all these criteria. So this is because the mineral oil, this is because natural ester or vegetable oil has a very high biodegradability levels. As we can see in these figures, the biodegradability levels of vegetable oil or natural ester oil is about 79%. This is much higher than mineral oil, which has only about 30% biodegradability. Natural ester can be classified into two categories. They are tree ester and monoester. The problem now is why monoester? Actually, vegetable oil of tree ester type have been used as insulating liquid in a transformer now. But the oil has high viscosity and also less resistant to the oxidative degradation. So the question that needs to be answered is, can the natural ester be modified to have a low viscosity oil, which also has a relatively high resistance to oxidation? So this question will be answered in our investigation. So the objective of our investigation are two. The first one is to develop a natural ester-based oil that has a low viscosity. And monoester type possibly the answer of this objective. And the second objective is to improve the oxidation stability of monoester by choosing only saturated fatty acid component. Palmitate and stearate acids are chosen to be the acid part of the monoester to fulfill this requirement. So in the experiment, we used two kinds of samples. They are isopropyl palmitate and isopropyl stearate. We prepare these two kinds of samples through the esterification. The esterification from isopropyl alcohol and palmitate and stearate acids based on this equation. So the experiments are conducted based on this standard. So there is a standard procedure which is listed in the right column. There is a specification that needs to be fulfilled. For example, so the evaluation of viscosity of the oil should follow the procedure based on the standard B445, and the viscosity of the oil should not more than 50 centistock. So let's go to the results. This is electrical properties. We can see here that the breakdown voltage of isopropyls stearate fulfill the standard value because its value is higher than the standard. While the isopropyl palmitate doesn't fulfill the qualification because its breakdown voltage is lower than the value specified by standard. However, in general, the breakdown voltage of both oils needs improvement. And this is the physical properties of the oil. We can see here that we already expected that the kinematic viscosity of the both oil is low. And the results show that the kinematic viscosity of both oil is significantly low. This value is even less than viscosity of mineral oil. We can also see in the table that the relative relative density of both oils are well below the value specified by the standard. And let's go to the chemical properties of the oil. You can see here that water content of both oil is remarkably higher than the standard. So this needs to be reduced in the coming investigation. We can also see in the top tables that acidity numbers of both oils is also far above the value specified by standard. The standard should be less than 0.06, but the experimental results show the acidity number of palmitate, isopropyl palmitate, 0.86 and isopropyl stearate 1.04. So both water content and acidity have a worse effect on the breakdown voltage of any insulating liquid. So if both of these properties can be improved, the breakdown voltage of the oil will be improved automatically. So let's go to the conclusion. It is found that the viscosity and relative density of both liquids meet well the specification standard, whereas their acidity and water content do not. The breakdown voltage of isopropyl stearate has fulfilled the standard value, whereas that of isopropyl palmitate has not. Reduction of water content, acidity, and impurities are required to improve the breakdown voltage to bring these oils to their implementation as insulating liquids. So thank you very much for your attention.